Hi everyone, I am a student at the University of Wisconsin-Stevens Point, and I'm going to school to be an elementary education teacher, and I'm currently enrolled in a math class, Math 338, that focuses mainly on middle school mathematics. Our main topic that we are learning about right now in class is geometry. So today I'm going to be teaching about the Pythagorean theorem. I'm going to start off by giving you some background about the Pythagorean theorem. Then we're going to talk about what the Pythagorean theorem is. And then at the end, we're going to do two different examples of the Pythagorean theorem. I would highly recommend following along in a notebook, taking a couple of notes, and doing the problems with me at the end because it'll only be more beneficial to you if you follow along. So, first off, to begin with the background of the Pythagorean theorem. So, the Pythagoreans were the first ones to come up with the Pythagorean theorem, and they proved that any right triangle, and we know triangles are right because of their right angle in the corner, so they proved that for any right triangle, the sum of the squares of the lengths of two sides, A and B, so we have our A over here, and then we have our B. So for the squares of any two sides, A and B, is equal to the square of C, which is going to be over here. So to write down our equation so that everyone has it, it's going to be A squared plus B squared equals C squared. So this is going to be our main equation for the Pythagorean theorem. This is important. This is good to keep down and write down. Okay, we're going to do a little bit of practice by plugging in some numbers and figuring out how the Pythagorean theorem works, and to just prove and to see that it is working. So if we first draw our right triangle, and let's say we know the lengths of two of the legs. We know that A is 5 and that B is 12. Now A and B, the sides can always be interchangeable. These two can always switch. This could have been 5 and this could have been 12. However, we need to make sure that we know the hypotenuse is always going to be C, and C can never be interchanged with A or B. And C up here is always the longest side of a triangle, and it's always across from the right angle. So now that we know that we have 5 and 12, we're going to solve for C. So if we plug this into our equation, that I'll write up here again so you can remember. A squared plus B squared equals C squared. So we have our A, which is 5. So 5 squared plus 12 squared equals C squared. Easy as that. Just plugging in numbers. So then we're going to figure out what 5 squared is, and we know that 5 squared is 25 plus 12 squared, which is 144, which equals C squared. So now we're going to add these two together, and that comes to 169, which equals C squared. Now we have to find the square root of both sides to get rid of that square. So 169, the square root of that is going to be 13. So C equals 13. So we could write in 13 up here, maybe circle it depending on how your professor or teacher would like it. So now that we've solved the problem where we had to find the hypotenuse, we're going to solve a problem where the hypotenuse and one leg is given to us, and we need to solve for the opposite leg. So we're going to start off by redrawing another right triangle. And then for this right triangle, we know that the hypotenuse is 17, and the hypotenuse is the side across from the right angle, so we know that this is 17. And then we know that one of the legs is 15. Now, again, 15 could go here, or it could go here. It doesn't matter. So we're going to pick to put it on the bottom. Now we're going to put it back into our equation, which was a squared plus b squared equals c squared. This is going to be our a, so we're solving for a. So we have a squared plus b squared, which is 15, equals c squared, which is 17. Now we are going to solve for the squares, so I would like for you to plug these into your calculator, maybe think about what they are. So for 15 squared, we should have got 225. And for 17 squared, we should have got 289. To solve for a, we need to get a by itself. So we're going to have to subtract, which is the opposite of adding. We have to subtract our 225 to get a by itself. So we would get a squared equals 64 after we subtract 225 from 289. Now we have to figure out our squares to get rid of the square. And the square root of 64 is 8. So again, we can erase our a up here and solve for a. Now to prove this to anyone, you can always just easily put these back into the equation and manipulate the equation until you get these answers. I hope that my teaching about the Pythagorean theorem was quick and easy and also very understandable. I hope that you took notes, and I hope this video was very beneficial to everyone. Thanks.